What actually shapes the true cost of a Salesforce migration? The answer is buried in one system-level trade-off, not the headline version. Everyone treats Salesforce lock-in like a pricing problem, but the real tension is much deeper. Once a business runs on its metadata, automation, and connectors, moving out means untangling a web of proprietary logic that was designed to be permanent. This is no tech. So what actually makes Salesforce platform lock-in so hard to escape? Is it the data itself, or the hidden system of business logic wrapped around it? Most people assume the trap is data gravity, and the logic seems obvious. Once you pour millions of customer records, support tickets, and sales histories into a database, it becomes incredibly difficult to pull them back out. Because of this assumption, teams often treat migration pipelines as permanent fixtures. They draw up a migration board, assuming they just need an extraction tool to pull the tables, and the job is done. They assume that once a connector is working, the data will just flow without interruption. But while working connectors can reduce setup effort, the pipeline itself still depends on Salesforce API versions, schema changes, and release-driven maintenance. Now, move from the procurement spreadsheet to the actual schema map. This is where the system begins to explain its own stickiness. Building on Salesforce usually lowers your infrastructure and operations burden because CRM hosting, identity, release management, and many standard workflows are bundled together. You do not have to provision servers or build a login system from scratch. But it is still expensive. You pay negotiated license fees, you pay for admin and developer labor, and crucially, you must design around hard platform constraints. Because Salesforce is a multi-tenant architecture sharing resources across thousands of companies, it enforces strict governor limits to prevent any one organization from monopolizing the servers. In a single synchronous transaction, you are limited to exactly 100 SOQL queries. You are limited to 150 DML statements. You have exactly 10,000 milliseconds of synchronous Apex CPU time, 50,000 queried rows, and roughly 6 megabytes of heap memory per transaction. These limits are not just suggestions. If your code hits them, the transaction fails entirely. To survive these constraints, developers can't just write standard code. They must write Salesforce-specific code. If an engineer tries to update 101 records using a standard database loop, the system throws that red error and rolls back the entire operation. Instead, they have to rewrite the logic to bulkify the query, moving it outside the loop into specialized maps and lists. Those limits often force asynchronous patterns like queuable Apex, batch Apex, and platform events, requiring extra test coverage just to deploy into production. And this is where the lock icon first appears. Control is less about data ownership than about dependency ownership. Salesforce creates switching costs by embedding business logic and governance across proprietary metadata and runtime layers. You are not just storing a record. You are storing sharing rules, permission sets, roles, flows, Visualforce pages, Aura components, and Lightning Web components. Managed packages add namespace-bound and sometimes protected components, so third-party app exchange functionality is not a simple copy and paste to another CRM. Every time a team builds a workaround for a governor limit or installs a managed package, the schema map grows more complex. And that schema map is about to encounter the reality of the cloud. Open the developer terminal. Look at the release notes. Salesforce platform changes force recurring enterprise decisions about whether to upgrade now or stay pinned to older behavior. Because the platform ships 3 times a year, changes constantly affect Apex, metadata, and user interface behavior. That same lock-in logic shows up in our episode on why Oracle counts 64 cores as 32 processors. We broke down how Oracle turns a nominally technical migration into a costly exit through vendor-specific policy constraints. That one goes deeper into this exact mechanism of enterprise dependency traps, and it is worth a watch if you want the full breakdown on the infrastructure side.
But here, Salesforce takes that pattern and applies it directly to the API and metadata layers. A major example is the retirement path from workflow rules and process builder toward flow. This forces organizations to redesign automations, retest side effects, and decide whether to refactor legacy logic or keep temporary technical debt. Another common forced decision is the classic to Lightning transition. Teams must choose whether to preserve old Visualforce pages, rebuild in Lightning web components, retrain users, and rework page layouts, quick actions, and mobile user experiences. Regulated enterprises also have to decide on their Hyperforce region data residency posture, shield platform encryption, event monitoring, and field audit trail, mapping those choices to GDPR, HIPAA, or SOC 2 controls. But the most dangerous changes happen quietly, at the integration layer. Integrations become sticky because many enterprises standardize on the Salesforce REST API, SOAP API, Bulk API 2.0, Metadata API, Tooling API, and Change Data Capture. API and platform version changes force choices about whether to keep old API versions for compatibility or upgrade and risk breaking integrations, tests, or managed packages. Google Cloud Data Fusion release notes explicitly warn that Salesforce API field deprecations in version 60.0 can break pipelines and require manual schema updates. If a downstream data warehouse expects a specific JSON payload and the new API version drops a deprecated field, the pipeline does not gracefully degrade. It crashes, taking down executive dashboards and triggering a severe incident just because a back-end label changed. This is where the red error returns. Small platform changes create outsized operational risk. Hold that thought, because the answer shows up when a single API version changes and the pipeline that looked finished starts failing again. If zero ETL and bidirectional sharing can move data so easily, why do enterprise migration budgets still balloon when teams try to leave Salesforce? Which brings us to the modern promise of seamless data. Shift your view to the Google Cloud Console, specifically a modern integration architecture connecting Salesforce Data Cloud to BigQuery. Today, the industry talks about Cloud Data Fusion, BigQuery, ETL, and ELT. The promise is that data can flow freely. You can query Salesforce Data Cloud directly from BigQuery without building complex infrastructure. The marketing promise is that zero ETL or bidirectional sharing removes switching costs entirely. But data sharing is not the same as a full platform exit. Moving the records is easy. Moving the rules that govern them is where the budget breaks. Remember the schema map we opened in Chapter 1? This is the reality of field drift. The schema keeps moving, so migrations never stay finished.
When an administrator adds a new custom object, changes a pick list value to reflect a new sales territory, or alters a master detail relationship in Salesforce, that field drift has to be manually mapped, tested, and deployed in the external warehouse. The data moves, but the structural meaning requires constant human translation. If a downstream system expects a specific string and receives a new ID format, the pipeline silently corrupts the reporting layer. If you use a zero ETL connector to push data to a warehouse, you have the raw records, but you do not have the validation rule that ensures a discount cannot exceed 20%. You do not have the sharing rule that prevents a junior sales rep from seeing an enterprise contract. And you do not have the SAML 2.0, OAuth 2.0, and SCIM identity wiring that dictates exactly who can log in and what they can view. The evidence keeps pointing to the same thing. API changes break pipelines, zero ETL only reduces transfer friction, and the expensive part is still re-encoding Apex, flows, and permissions. Back to the migration board we opened at the start. Most teams assume the hardest part of leaving is extracting the 10 terabytes of historical records. But the actual bottleneck is the 6 million characters of custom Apex code and flow logic that tells the business what that data actually means.
Leaving Salesforce is usually the larger one-time cost, because you must export and remap data, rebuild object and fields, rewrite Apex and Lightning logic, replace AppExchange packages, rewire integrations, and run parallel systems for compliance revalidation. Look closely at just one of those sticky notes on the migration board: rebuilding the security model. In Salesforce, visibility is controlled by a dense matrix of profiles, permission sets, role hierarchies, and sharing rules. When you move to a standard SQL database, none of those concepts exist natively. You have to architect an entirely new row-level security model from scratch, map every user identity through your identity provider, and prove to your compliance auditors that the new system enforces the exact same data residency boundaries as the old one. And while you are moving those sticky notes across the migration board, the platform keeps updating. Those release notes we looked at in Chapter 2, they prove the platform keeps changing underneath supposedly stable integrations. API deprecations turn integrations into living maintenance. Zero ETL moves data, but not platform-specific logic. Metadata, permissions, and automation are the real migration surface. Lock-in is hidden work, not hidden data. So the lock-in story resolves here. Salesforce does not just hold data in place. It accumulates the hidden work required to make that data usable, governed, and portable in any other system. So, what does it actually cost to leave? The truth is, there is no reliable universal dollar figure. The evidence supports the existence of switching costs, but not a precise total cost of ownership or exit cost number. What we do not know is the actual contract price, the number of custom objects, how much business logic is declarative versus code, and whether the migration is incremental or a full rip and replace. We also do not know the exact portion of lock-in caused by technical architecture versus procurement, contract renewal terms, or embedded business process ownership. But we know exactly where the friction lives. Look at the object we started with, that terminal throwing the API deprecation error. The reality of platform lock-in. By the end, the red error on the screen is the point. Salesforce migration switching costs are not mainly a licensing line item, but the compounded cost of recreating metadata, automation, and permissions. But the true cost of exiting Salesforce opens a harder question. What would it take to replace it without raising the failure budget? We follow the evidence at the API, schema, and automation layers to show how convenience becomes maintenance and maintenance becomes switching cost. If you've done a Salesforce migration, comment with the one layer that broke first: schema, automation, or permissions. See you on the next migration trace.